This is my talk about how I automated my barn with Arduino, Raspberry Pi, Micronaut, streaming, Docker, Kubernetes, autonomous DB, and the cloud. And there's actually a few extra pieces that I left out of that because that's a ridiculously long title. This is the safe harbor statement that Oracle makes me put on all of my slides, and that's about enough of that. Here's the agenda. We're going to talk a little bit about the background, some of the architecture, the code flow, and then we're going to get into some other cool stuff. About me. First of all, I'm a full stack developer. I've been a full stack developer for 15 years. And I always say that right up front because to me, that's what I always will be first and foremost. I worked with Groovy and Grails. I was actually a Cold Fusion developer. Does anyone want to admit that they were a Cold Fusion developer? There's one. Yeah, I admit it. I started with Cold Fusion back in 2004, and around 2011, moved over to Groovy and Grails, and do a lot of TypeScript, some JavaScript, and Node, and I like to use Angular on the front end, and we'll see a little bit of that. Although a lot of the stuff we're going to see today is in Groovy and Grails, I tried to structure it in such a way that it'll look very familiar to a Java developer. Does anybody use Groovy? Yeah, a few? Just for like Jenkins scripts or testing, Spock, Jeb. Yeah, there's some really cool stuff, but I've always been a kind of dynamic language kind of guy, so that's why I like Groovy a lot, which is funny now that I'm getting into Micronaut. You kind of get better advantages by using like the static compilation. But yeah, I love Groovy and Grails. So I'm actually paid to be a cloud developer advocate for Oracle. Used to work at AT&T and a consulting firm, Booz Allen Hamilton. But like I said, first thing first, I'm a developer. I just get to do fun things like come talk to people about things and show them the cool things that I work on. So I was born here. Anybody know where that is? $5. No? Cleveland, Ohio. He's like, yeah, that's Cleveland. And unfortunately, I am a Cleveland Browns fan. I've suffered through. Hey, next year's our year.
They always say that.
Yeah, we've been saying that for a long time. But we'll see what happens. So I was born in Cleveland, Ohio. Lived in the close by for the first 22 years of my life. After that, I moved to a tiny little suburb called Medina, Ohio. So I went from the city to the suburbs. And then back in 2014, I moved to here. And this is Blairsville, Georgia. It's about 2 hours north of here, right close to the North Carolina state line, right on the edge of the Appalachian Mountain Range. And the reason I tell you this is that so you don't, I was born in Cleveland, so I'm not just some southern redneck hick. I actually do have kind of a little bit of city in my background. No, the reason I tell you that is when we moved here, we did what a lot of people do, and we bought a barn, and we got a pig and some chickens, and this is my backyard, and started our own little hobby farm, what they call. And when you start a little hobby farm, it's all fun. You have a nice little pig to pet, you get some eggs, but then you start to realize that it's kind of a lot of work, right? I mean, every morning you have to get up and open the barn up and feed the animals, make sure they have fresh water throughout the day, and especially here in Georgia where it gets pretty hot in the summer, you have to always take care of them and keep an eye on things. And then at night, you have to go out, and at least my chickens, because they're spoiled, you have to turn the light on for them, otherwise they can't find how to jump on the roost. And then you have to go back out about a half an hour later and close up the barn, lock it up, turn the lights back off. So what I kind of realized quickly is that, hey, this is an opportunity for me to do a little bit of automation. And that's what I did. So about 3 years ago, I built the initial part of this system. And it was powered by a Raspberry Pi, and it was just kind of basic. Just had a few sensors. This is the enclosure. So we have a temperature sensor here, an RF transmitter. There's a webcam, and this is what it looks like installed in my barn. So there's a door sensor there. We have a webcam right there. That's the temperature sensor, and that's the door sensor over there. So it was just basically to do some simple tasks, and it was really just an excuse for me to buy a Raspberry Pi and play around and learn some new stuff, right? This is what I call version 1. So it had temperature and humidity monitoring. It had the door sensor. It had a flame sensor because I had one. It came in the kit that I bought, so why not? One of the cooler things is the RF outlet control. So I bought these little RF controlled power outlets that you just plug in, and then you plug in whatever you want to control into that. And it has a little remote so you can turn them on and off. But it also has the ability to be controlled from the Pi with that RF transmitter that I just showed you. There's a webcam stream, and the web-based interface that you see on the right-hand side here was used to kind of show that data in real time. The downside was that it was local LAN only, right? The other shortcomings is, like I just said, that it's not web accessible. So I didn't want to risk opening up my firewall and being able to access it from the internet. So I left it local LAN only. I had limited features. It only had the RF outlet controls and the temperature sensor and whatnot, but there was no motorized doors. I couldn't open the doors. There was no automated feedings. So basically what that meant was, while it was nice to have for sitting around the house and doing some minor things, if I wanted to come down to Atlanta for a day trip or something, I still was kind of out of luck, really. I couldn't count on it to refill water. I couldn't count on it to feed the animals or open the doors or these kind of things. And there was no data persistence. So it's just real-time data coming through the web app, and there's no database behind it. So when I started at Oracle back in September of last year, I thought back to this project and I thought, well, what can I do if I wanted to rebuild this system? If I had like an unlimited budget and I could just host anything I wanted in the cloud, how would I build it? And that's how I came up with these requirements. Obviously, first off, it was going to be cloud-based, right? Because I'm a cloud evangelist. Plus, it was a really good way for me to learn about a lot of the services and products that Oracle offers. I wanted a real-time web-based interface. So I wanted a real-time web-based interface, and what I mean by that is I wanted to push data from the Pi to the web browser in as close to real-time as possible. I wanted to add data persistence for trend analysis and potential machine learning. So one of the things I could do is, like when I tell my 11-year-old son to go out and close the door, and he doesn't, I could actually look at the database and say, hey, you never closed the door when I told you to, right? I wanted to add automated feeding and watering, and we're kind of almost all the way there. I wanted to add mechanized doors, and I wanted it to be remotely controlled. So obviously, if it's cloud-based, I would have the ability to send commands back to the barn and control it remotely. So what I ended up building was a prototype, and that's what we're going to see today. And the reason why it's only a prototype right now is because it's really easy to demo to you when it's sitting on my desk, and it would be a lot more difficult to demo it if it was out in my barn. Plus, it would cost a lot more money if I were to get like full-size motors that actually open full-size doors and whatnot. Those are a couple $100. Whereas a little Arduino motor costs about $5. So it's a lot easier to demo. But what I built was this little kind of mess of wires and sensors that you see in front of you here. And I'll demo that for you right now. This is actually a video that's kind of my backup plan in case things really go sideways, but it shouldn't. So we'll take a look at that. All right. So the first thing we'll do is figure out why VNC is halfway off the window. Let's try that again. All right. So I'm going to remote into the Raspberry Pi. And actually what I'll show you real quick here is, since I'm connected to my local network right now with the Pi, I'll show you version 1, and then we'll start up version 2 and go from there. All right. So this is the web interface for version 1, and I said it was not web accessible, and technically it's not, but I'm kind of cheating by remoting into my machine and accessing it that way. So right now, the door is open, the flame sensor is reporting okay. It's 67 degrees up in Blairsville, and the relative humidity is 77%. I have 2 jobs scheduled, one at 7:39, so in about 21 minutes. The lights will turn on, and then at 9:09 the lights will turn off. That gives the chickens plenty of time to come in and jump up and get settled. If we click on the webcam feed, that's a live view inside my barn right now. It's a little bit of a mess. I should have cleaned it up. But it's kind of nice because if I'm sitting on my couch at home, I can pull this up and make sure all the chickens made their way in, and then I could turn the light off directly from this web interface. But as I said, it's kind of limited, but it kind of did the job it was intended to at first. So what I'm going to do now is start up a script. That error always happens the first time, so no need to panic. And we're publishing new data. And if we come over here, okay. Cool. So right now, live data is being pushed directly to the web interface, and this is version 2. So we have a real-time kind of temperature chart on the right-hand side here. It's showing you the degrees in Fahrenheit and the relative humidity. If we come over here, actually, let me turn that light on so you can see a little better. Yeah, so it's on my desk there on the left-hand side, and the light's about to turn on. It should be able to see a little. There we go. So over here, this is my office, and here's a door that's controlled by a motor built with Legos. Here's another door that has a solenoid-driven lock. That's a Lego pig. And here's the water supply, right? So the theory is that I'd have the ability to do automatic watering by either having a source kind of water supply, which is shown, simulated by this one on the left, and then kind of like the pet bowl here on the right. And then there's this right here is a water level sensor. So the theory is that you have a 55-gallon drum or something of water, and you could also do it with a pump, maybe with a remotely controlled solenoid, pump for the water, hooking it up directly to a water line instead of a bucket. But for the demo, it's just a source jar and then a pet jar. And the theory is that as the pet drinks the water and the water level falls below a threshold, the pump will automatically kick on and refill it. And right now, if I enable the pump, we should see that there's a little bit of a lag on the webcam here, but you can see the water level is already starting to rise over here. It looks like the webcam is a little frozen. But as you can see on the right-hand side here, the water level is rising. You can't see the pump really moving because the webcam is so laggy right now. But the water level is rising, and once it reaches a specified fill threshold, it'll shut off. Or if I disable it manually, it will also shut off. So you can see as it's leveling off, right at about 104 milliliters. And if we come up here to the top here, we can do things like turn the lights on or open the door. And if the demo gods, there we go, the light turned on and the door opened, and there's the chicken standing there ready to come out. The solenoid door, if I were to demo it, you'd see the latch come down. But what I really want to do with that is add like a linear actuator that kind of opens that door, and that'd be a little more impressive for demo purposes. But so that's essentially the prototype. We can close the door and turn the light off. We see the status of the door over here is closed, and the door's closed, and the light's off. So that's my little demo. The other kind of piece here is over here. Hard to see, but that white screen right there is a digital photo frame. And what I have in that is some random pictures that are cycling through. And the thought is that I would be able to hook up a camera to the barn and have a motion sensor attached, and the motion sensor is right there. And it would sense motion, and it would take a snapshot, and then it would upload that to a server. The theory being that I could do some kind of predator detection based on that. So here's when the pump kicked on, it tripped the motion sensor, and it took this picture of the picture frame, and it has some trees over here on the right-hand side. So we can also manually trigger that. And if my serverless function is working properly, what we'll see is a text message come to me, and it would let me click on the image and view the image. And there's some kind of identified concepts here as to what was located in that. And kitten is not how I would describe that bobcat, but apparently that's what the AI program that I used has come up with here. So essentially that's the system. And now we will take a look at some of the code behind it. Let's shut this down. Oh, stuck in there. All right, so let's talk about the architecture a little bit. The Arduino, there's an Arduino within that housing, and I like to kind of think of it as the heart of the system, right? So like any body, your body couldn't live without the heart, right? It pumps all of the data out of the system. The Raspberry Pi is connected to the Arduino via a serial connection, and I like to think of it as the brain because it's just as important as the heart, but it does some logic. It applies some actual logic to the data that it handles. What was originally a Kafka queue and now is OCI, Oracle Cloud Infrastructure Streaming, is the stomach, right? So what does your stomach do? It accepts input and it produces output, right? That doesn't mean my data is shit, but it's what it does, and I couldn't think of a better analogy. The microservice side of things is the digestive system, so it accepts that input and it kind of does something with it, right? So just like your digestive system stores nutrients and fat into your body, the microservice will kind of push it along, but it will also store that data in the database while it's doing its thing. The front end is the skin. Obviously, it's what you see when you look at the system. The database and object storage is the fat. It's where all the data gets stored. Cloud events are wired into the system, and they're the ears, right? It listens for something to happen. In the case of this system, it listens for an object to be persisted into object storage. And just like your hands respond when your ears hear something, unless you're my kids, the serverless portion of the system is the hands, right? It does something. So if I asked you to pick up a pencil off that desk, your ears would hear that, and then your hands would do that action, right? And the cloud notifications piece is the mouth. It kind of says, I've done something. So, you pick up your pencil and say, I've picked up the pencil. And that's kind of the architecture. And this is what it all looks like in a pretty little diagram. Up here, we have some sensors connected to the Arduino, which is connected to the Raspberry Pi with a serial connection via USB. There's some sensors attached to the Raspberry Pi. The Pi pushes data to the message queue. The microservice up here is a Docker container with a Micronaut application deployed on a Kubernetes cluster. And the front end is an Angular application, also in a Docker container, also deployed on Kubernetes. Down here is object storage, over here is the database, and FN is the serverless function piece of things. And all of that fun stuff is in the Oracle Cloud. So let's take a little look at the outgoing flow. As we've seen already, the Arduino reads the sensor, formats the data, in our case JSON, and then just prints it to serial, right? So it just loops constantly. Anybody work with Arduinos much? A couple people, okay. So it's as simple as it can really be when it comes to computers. There's like a setup function, like an initialization function, and then there's a loop function. And all of your code happens in that loop function. So all it does is every time it loops, it reads the sensors, and it just dumps it out to serial. So if I were to turn it on with nothing connected to it, it would just keep doing that over and over. The Raspberry Pi reads that serial, it parses the JSON, and then it posts it to an outgoing messaging queue. So like I said, originally it was Kafka, now it's Oracle Streaming, and it just posts it up to a topic that's configured to produce messages for outgoing messages. The microservice consumes that topic, persists the data to the database, and then it just emits events within itself for potential event source endpoints. And finally, the front end establishes that event source in JavaScript, consumes the real-time service and events from the microservice, and displays it. So here's a little bit of some of that code. The first piece here is just an example of the Arduino, which is Arduinos use a slightly modified version of C++, and I am not a C++ programmer by any means, but this is what some of that kind of looks like. So the first thing we have there is a function on line 4 that collects the temperature. And like I said, all it does is reads the pin that the sensor is connected to, and it returns that data. And then down on lines 9 to 15, I just create a JSON object and just create some kind of nested objects containing that data. And then finally, at the end of the loop code, I just print all that out to serial. The Raspberry Pi, as I was talking about with Laura, uses serial. And there's a library that I use called JSerialCom. Have you used that? Yep. Yeah. It's a nice program, and I just recently made it a little better, and I don't even think that this reflects it. But it's nice because it can read from serial up to a delimiter, which I was having problems initially with reading serial because, especially with JSON, right? You need a whole JSON object in order to parse it into an object. And so sometimes it was getting kind of half packages, and there wasn't really any predictable way. So with this library, I just had it read until a delimiter, which is a new line, and that way it made it a lot more reliable. So what this does is it just does kind of a loop and checks if there's any bytes available on the serial port. And then it reads that into a byte array. It establishes a byte array, the size of the bytes available, and then reads it into the byte array, creates a new string from the byte array, and then parses it into an object, right? So in this case, I have a array of messages. Down here, we just make sure that we have some messages, and then we just loop over them, and then call that message producer service and send, converting it back to a string. And the reason I kind of do that dance of parsing it into an object and then converting it back to a string was, like I said earlier, sometimes I would only get kind of part of a packet. So I wanted to make sure that I was publishing an actual well-formed JSON object instead of half of one. So again, it just posts it up to the queue.
How do you know the end of the marker for you to slump the data in?
Say again?
How do you know the end of the marker for you to be slumping the data that comes out of the serial and construct it as a JSON?
So there's a way with JSerialCom to read until a delimiter. And so when I'm printing it to serial in the Arduino, I just put a new line at the end of the print. And on the Raspberry Pi side, I just read everything until that new line, right? And it's actually in a try-catch, so I make sure that I'm actually getting a valid JSON object and reading it and parsing it correctly before I produce it up to the thing. If it doesn't, I mean, we're talking about dozens of these a second, right? So if it misses one or two, I'm really not all that worried about it. I just kind of fail silently and just move on with my life because, you know, I'm just missing one or two events. But it's pretty consistent in that it doesn't error out too often. And that's actually when I started up that script on the Raspberry Pi, the first thing you saw was that error. That's because the first thing it read, it only read part of the packet, and it just said, I can't do anything with this. And then it started consistently publishing those messages. So this is the message producer service, and this is how I use the Oracle Cloud streaming to produce the message up to the streaming endpoint. So on line 3 there, we just use a put message details builder, and it just creates a message details object. Then I create a put message request, and then I call put messages on the client and just send that. So it just takes any kind of object. In this case, it's a JSON string, and I just broadcast that up to the streaming endpoint. So at this point, I kind of realized there was a problem when I was developing it. On the microservice side of things, I wanted to consume all events from that streaming topic all the time, right? So even if there was nothing connected on the web side of things, I wanted it to always consume those, because otherwise it would kind of defeat the purpose of having the data persistence. I wanted it to always record, even if I wasn't connected. At the same time, I wanted, like I said, to push all of those events in real time to the front end, right? And technically, I could create a streaming consumer and read those messages twice. Excuse me. But I wanted to make sure that I was committing all of those messages from the stream. So in that case, I couldn't do that, because if you have two clients connected and one commits a message, then the other client's not going to be able to read it. So the solution that I came up with was to use the observer pattern, and we'll take a look at that. So on the microservice side, the first thing I do is create a cursor, and this is using the Oracle Cloud Java SDK. If you're wondering where I'm getting create group cursor details and all of those things from, it's the actual Oracle Cloud Java SDK. So I create basically I create a cursor on the left-hand side here. And then on the right-hand side, I just loop in an infinite loop, basically. And I call get request. I have a half a second sleep down at the end, so every half second, it checks that streaming endpoint, and it consumes it. If it has something over here, we parse it. That's a little hard to read. I'm sorry that I need to make that code a little bigger. But it parses the JSON from the streaming event. And then it creates a barn event on line 13, which is just a pogo that I have that represents the type of event that it is, whether it's a door event or a light event or a water event. Converts that data to JSON and stores the captured timestamp. And then I have a barn SSE event. And down on line 26, I save it to the database. But right before that, I have a barn event bus that I use within the application to broadcast that event. So it's basically just a really simple event bus that I'm broadcasting messages to, and this is what that looks like. Anybody work with Micronaut? Only a few, huh? So I had this originally written in Helidon, which is an Oracle kind of micro profile framework. And I had kind of created my own event dispatcher system, and it worked. But what Micronaut uses is RxJava. Anybody use that? A few? It's kind of hard to get my head wrapped around that. What about you? You pretty comfortable with it?
We have a wrapper layer around it.
Okay.
I don't really interface.
Yeah. The whole reactive kind of functional programming thing in my mind is, it seems simple, but I just can't seem to really grasp it. But basically what it is there's a publisher on line 6 there that I create, and there's a send method, and then it just calls the event bus .onNext. So it calls the publisher's onNext method, and it passes that event along. So it's, as I said, the consumer just runs. As soon as the application starts up, it creates that consumer in a thread, and it just runs whenever that web application is running, and it persists those events to the database, and it broadcasts to this event bus. Bless you. If nothing's connected to the event bus, that's fine. There's nothing to be consumed. But in my endpoint, this is where I actually connect to the event bus right here, and I call the subscribe method. And it just accepts a consumer, and then within the consumer I have an accept method, and then I just broadcast that. And for server-sent events, what Micronaut uses, again, is RxJava. And all they require you to do is create a publisher with flowable.generate, create an initial event state. In this case, it's just a null, empty barn SSE event, and then pass it a generator function, which is what you see on lines 6 to 25. And within that generator function, I just subscribe to that event bus. When I get a notification from that, I call the emitter.onNext function on 15, and that's what actually broadcasts the server-sent event to the connected consumers. So here's what that flow kind of looks like animated. The data comes from the sensor to the Arduino to the Pi, which posts to the message queue. The microservice on the right-hand side there consumes that queue, pushes the data to the front end, and also stores data down in the database. Now what about incoming, what I call the incoming flow, right? And that's data going from the web to the barn. So I wanted to capture based on user input, whether I wanted to click a button as we saw, or a link, or those types of things. And what I then do is I post it to an endpoint on the microservice. Instead of creating any kind of socket or open connection constantly just to listen for events going back to the barn, since they're much less frequent, I decided to kind of just do it in a traditional post manner. The microservice then kind of does the opposite of what the whole entire previous flow does. It publishes to a producer, or it calls a producer to publish to a stream going the other way. So I use the event stream both ways, but in a slightly different manner. The Raspberry Pi consumes that incoming topic, and then if it needs to, it writes to the serial connection, and the Arduino will read that serial connection, and it'll do something if it has to. So on the Angular side of things, we just have a function here to control the door, for example. I pick which door I want to control, and then on line 11 there, I call a data service, and I send a control message. And then down on 18, it just makes a simple HTTP call, and it posts to that barn control endpoint, sending it the message. And the Arduino message going this way, I basically use a series of common constant values throughout the entire architecture. And it's just, Arduino open might be represented by 1. And the door constant might be 101. So it's basically to keep the package as small and light as possible. No sense sending huge strings across when there's possibly many things going on. The control endpoint on the Micronaut application consumes and produces JSON. And then again, it just calls a message producer and it sends that message to that topic. The consumer on the Raspberry Pi side of things looks almost identical to the consumer on the microservice side of things, with the exception of over here on line 7, it calls an Arduino service send method. And that just uses jserial.com down on line 4 to write those bytes to the serial connection. So instead of reading the serial connection, here we're writing back to it. On the Arduino side, it just reads the serial, and then it uses a switch case to figure out what it needs to do. If I'm talking about door number 1, maybe I need to turn on the motor, and then which do I need to run it forwards or backwards? So I just look at the message that I sent, and if it's open, then I want to run it forward, and if it's not, then I want to run it backwards. So essentially that's it from the incoming flow. And what that looks like is data from the front end to the microservice, pushed to the message queue, to the Pi, and to the Arduino, and then possibly to the sensors or motors or anything connected to that. So the motion sensing image capture that we looked at earlier, the motion sensor runs on the Raspberry Pi. The Groovy script that runs on the Raspberry Pi creates an event listener for motion events via Pi4j. And if you get into any Raspberry Pi programming and you want to write a JavaScript, Pi4j is a really awesome library, and it basically allows you to interact with the GPIO pins on the Raspberry Pi and write Java code that you're already comfortable and familiar with. So you can actually do things like create event listeners that react to state changes on the sensors directly in your Java program. So in my case, I have an event listener. When the motion sensor is triggered, it will take a picture with the camera. Then what it does is it uploads the snapshot to Oracle Cloud Object Storage. And the cool thing about it is that it uses the Amazon S3 API. So I actually have the Amazon SDK, the AWS SDK in my jar, and I use all of the methods within the Amazon API to do the upload. When the object gets uploaded to the bucket, that action triggers a cloud event, which then calls a serverless function. The serverless function analyzes the image using a image analysis library, or API. And then finally, it sends a message to the messaging queue to notify so that the front end can know that an image has been captured and you can display the image on the website of things. So this code looks like this. As I said with Pi4j, you can add listeners to your sensors, and in this case we have a GPIO pin listener, and we just override the handle state change event method. And so every time that motion sensor detects a state change, whether it's detecting motion or stops detecting motion, it'll be called, and then in this case I want to make sure that it's detecting motion and not turning off, so I check for pin state high. And then I call a camera service and I take a picture, and this is how the camera service does things. It creates a new file, stores the picture to a local file on the Pi, calls the producer and says, hey, we've taken a picture, the front end can display it, because now that it's been stored. And over here on the store side of things, as I said, if you've used the AWS SDK at all, this code should look really familiar to you. You just create an object metadata object, create a put object request, and then you call your client and send it that put object request. And the reason that this is cool to me is that your existing code bases that you may use a lot of AWS S3, you can easily migrate them to Oracle Cloud with no code. Well, I take that back. You do have to modify the endpoint of your client slightly, but it's like 2 lines of code. So you can migrate your entire AWS S3 application that uses AWS S3 to Oracle Cloud with only 2 lines of code changing. You don't have to swap it out and use the Oracle SDK to do object storage. it just works. It's fully compatible S3 endpoint. So this is using the UI in Oracle Cloud. This is how I set up the cloud event that listens for that object. So I just give it a name and a description. Event type down here. When an object storage create object event happens on the bucket name of barn captures, I want to take an action of calling a function, and this is the Oracle serverless function that I'm calling. Here's the actual serverless function details, and then here is the notification topic. So this is kind of like Amazon SNS, so you can have you can broadcast notifications. And within Oracle Cloud, I just set up a subscription to this topic that sends an email. And I kind of use a little bit of a hack down here where almost every mobile phone, did you know, has a email address that you could use to send it text messages. And it's usually, like in my case, it's my phone number at message.fi.google.com. But AT&T, Verizon, they all have an email address that you can use to send text messages. So since notifications doesn't support SMS currently, I kind of use this little hack to get a text message on my phone. And the thought is that right now it's just sending everything, but I could set it up to only send me a notification when it detects a predator, a bear or a lion or something within the image, so that I can be notified when that happens. So this is the serverless function. Using FN, has anybody used FN project for serverless? No one. Well, I know what I'm going to come and talk to you about next, because FN is really cool. It's serverless functions that are basically run in a Docker container. And you can host your own FN server, or you can, well, I shouldn't say you can now because it's currently in limited availability, but Oracle Functions is a hosted serverless offering. So you can spin up your own FN server and host your own if you wanted to, but coming very soon, and what I'm using with this is the hosted serverless option. So this particular function gets called, as I said, every time an object storage, an image gets stored to object storage, and it receives an event. And within that event is just a JSON string containing details about that event. And there's other kinds of events. You can do events for database backup or database shutdown. So you can subscribe to all kinds of different cloud events that get broadcast and let you take actions based on that particular event. But in this case, it's a JSON object containing information about the object that was persisted to object storage. And it contains data like the namespace, the bucket name, and the object name, so that I can construct that image URL on the second line there, and that's the location where the image is stored in object storage. My bucket is public, so I don't have to do any pre-authenticated request, but if my bucket was private, I could create a pre-authenticated request to access it that way. And then I use the Clarify API, which is a open source, I don't know if it's open source or not, but it's a system that does image recognition, and it's like AWS recognition and those kind of things, where it actually will look at your image. You can create models to train it to do image recognition. And in this case, I just pass it the URL, and I get a list of concepts, what they call concepts back. And what a concept is just an item that it detected in the image. So like I showed you that text message earlier, kitten or tree or person or these kind of things. And it's just a list of all those concepts that it identified. I loop over those and I just create a string, and I use that string inside my message. And then using the Oracle Cloud SDK, I send a notification to that notification topic that I showed you just a second ago. And so what that does is it sends me the text message on my phone. So as I said, I could put in an if statement here that if the concepts contains bear, and limit it just to that. And what that looks like is I can either trigger it from the take snapshot button on the front end, which goes to the microservice, to the message queue, and to the Pi, or the sensor itself. The motion sensor can trigger it and persists the item to object storage, which calls the serverless function and sends it to my text message. The next piece I want to talk about is Oracle Autonomous Database. And originally when I created this project, this is my playground project. Everything I want to learn, I just swap out something and change it and make it use something else instead. So originally, I used MongoDB and just stored everything in Mongo, and because to me it's just a place to store the data. And as long as I had the data stored, I could get it back out. I didn't really care about it. But then a coworker of mine, who's actually now my boss, Gerald Wenzel at Oracle, said, "Why don't you use Autonomous Database?" And I said, I don't, because the events themselves can have different data in them, right? So a temperature event, the JSON could be, Fahrenheit and Celsius and humidity, whereas a water event could be water level. And I don't want to create a different table for each type of these events, so I just want to store that JSON in a column and be done with it. But he told me that I had no idea was possible. You can actually, Oracle Database actually supports JSON columns in it. And it's not just a matter of stuffing a JSON string in a column. It actually fully supports it. And you can actually query that data as JSON by using something like this. So it's a simple query here. Select all from barn event, where data down here is a JSON string, but I can actually do things like where the data.Fahrenheit is greater than 75. And it'll actually parse it out as actual JSON, look within that, and let you do queries based on the JSON data in itself. Which is, as I said, really cool to me, because one of the things I never really cared about Mongo is that the API was always I never really fully grasped the API. It was okay, but I never really embraced it because I've been using SQL for 14 years, and I know SQL, I'm pretty comfortable with SQL. So to be able to kind of have the best of both worlds, to me, is a really cool thing. And so in summary, I use this kind of personal problem, and I say problem, but kind of personal challenge to learn new things. As I said, it's my playground. Try to think about non-traditional usages of tools and services. So kind of like how I hacked the notification system to sending me a text message when all it supports is email. One of the things I always like to do is kind of think, how can I break this? How can I bend this and make it do what I need it to do? Message streaming and queues are awesome. I had never really worked with streaming or Kafka or any of that until this project, and I really wanted to learn it, and it seemed like a perfect way to do it. Complex problems do not require complex solutions. Not that opening a Lego door on my desk is a complex problem, but it's not a trivial thing to be able to stand here in Atlanta, or last month, like I stood in Madrid and be able to open a Lego door from 4,500 miles away. That's kind of a cool thing to do. But in totality, I don't think that it's a really complex solution. My code's on GitHub. You can go look at it. It's not really a ton of code that I'm using here to accomplish all of this stuff. The other nice thing is that architectures with different languages and dependencies and frameworks can work together easily. So I kind of came from that monolithic architecture where, you had your big, huge jar, your Grails application or whatever it is. And, if your user service wanted to use a new feature of Spring Security, well, that whole application had to get upgraded to Spring Security, whatever, because it depended on it. And that might break something in another piece, right? So now that we've kind of moved to this microservice world, each kind of different piece can be have its own dependencies, have its own versions, its own languages. I wrote a Node microservice side of this and a Node Raspberry Pi client just so that I can kind of see if I could do it. And they all work together pretty easily. Real-time data push is possible with server-sent events. I used to use WebSockets a lot, but server-sent events are a lot kind of nicer in my opinion. Does anybody use server-sent events? a couple people. Yeah, I hadn't messed with them, but they're really kind of easy to do. And if you ever need any kind of real-time push to your front ends, I suggest you take a look at them. And then finally, you can store JSON documents in a traditional RDBMS system. And from what I understand, SQL Server supports it, MySQL, most of the engines support this now. And I had no idea that this was even a thing until 6 months ago. Here's my contact information. Oops, sorry. I'm Recursive Codes on Twitter if you want to kind of interact with me and ask me any questions or make fun of me, anything. I'm cool with that. Some of the resources that I've used here, again, Pi4j. All my source code is up on github.com/barnautomation. Oracle Event Hub, you can cut that out because I don't use that anymore, but that was the Kafka queue that I was using. Oracle ATP, Autonomous Transaction Processing, which is just our kind of PaaS version of Oracle database. JSerialCom, and then anything OCI related is that Cloud Native is at cloud.oracle.com/containers. Thank you. Any questions? Yes, ma'am.
Is that really your pig?
Yeah. That's Milton. That was on his first birthday, I believe. He's a potbelly pig. He's about 100 pounds. He's really docile and kind of friendly. He's just a pet. You know, he's not for eating or anything, but I wish I could get it. My wife grew up raising animals, and she would do like sheep and cows and pigs, but she would do them for 4-H where they would send them to auction. And when we got to this point, she's like, I'm not doing that anymore. I can't take a pet and send it to an auction and eat it later on. So this is kind of the best of both worlds. He has little tusks that are growing in. It's kind of crazy. Yeah, we do eat the chicken eggs though. But we won't eat the chickens when they aren't around any longer. Other question? Yeah.
Do you have any limitations using Docker on ARM? Or was that pretty straightforward?
So I'm not using Docker on ARM. I'm using Docker for the microservice, but I do have experience with that. I've created, and I don't know if I could, you probably won't be able to see it, but on my desk I have a 4-node Kubernetes cluster made out of Raspberry Pis.
Yeah, is it it has the plastic acrylic top? Yeah, that's it. It's pretty sweet.
Yeah, and I didn't even click in my mind that a traditional Docker image wouldn't run on those unless you used an ARM variant. So yeah, you have to use a special ARM variant of every image that you use for Docker, which meant that the reason I don't use that cluster very often is because of that. You know, I have to create a different Docker image to test it on my local cluster and then create a new version to deploy it to the cloud. So it's kind of a fun thing to say, yeah, I could do this, and I did it, but unless you're going to constantly use that, but then you have to hope that all those ARM images exist.
I saw that too. Some of the Linux operating systems, images you want to use just weren't available.
Right.
You had to stick with pretty popular ones.
Right. So what runs on the Raspberry Pi itself is just a groovy script. Well, it's a jar and it has a static void main, and it's just a jar that I run on the Pi itself. So it's not a Docker image, so I don't have to worry about any of that. So, yes, sir.
What other kinds of ideas tumble around your brain for applying these sorts of things?
As far as what?
Just
The whole project?
In your life like this.
Oh, so my wife is an occupational therapist, and she works with a lot of special needs children. And I haven't quite figured out how to cloud base it, but she keeps pushing me, help me create some technology to help my students out. So I've played around with resistive fabrics and creating buttons out of those, because some of the kids have very low motor control and they can't even press a button on a toy to turn it on. So their goal might be to turn on a toy because they're really low level. So I didn't end up doing it because we found a really huge button that I ended up wiring to the toy that the kid could press. But my next thought was, if I use resistive fabric and I create a gap between it, and he can touch this pillow of a button, when that fabric touched each other, it would create, close the connection and turn on the toy. So I didn't, but so that's where I'm kind of, I haven't figured out how to cloud base it yet, but my mind is kind of churning in that direction of helping her out with some therapy related project. She has all kinds of ideas, but I'm like, okay, so how can I put this in the cloud? What's the data? What can I do with it? But as far as this project goes, the sky's the limit. Temperature sensor might seem like a simple kind of thing to do, but we get pretty cold up in the mountains sometimes, and I have a heat lamp in my barn that when it gets really cold, I turn that on. So, the ability to be able to automate that coming on is, once the temperature drops below 30 degrees, turn on the heat lamp. There's all kinds of possibilities. Pressure plates where, when they step on the pressure plate, it opens the door. Or maybe like an ultrasonic noise emitted when a predator is detected, right? So that it scares, I don't know if that would work, but that's the kind of things that I think about, like scare off the predator by either maybe turning on a spotlight, those kind of things. So
maybe your wife could let the kids take something like that home, and then it could push the events to the cloud, and she could see like what kind of progress they're making with interacting with the toys.
Yeah. The problem is there's a lot of commercial products in that space, and not that that should deter me, but there are companies with lots of money and technology and teams behind doing that sort of thing. There's like gloves, tactile gloves that collect data, from motor muscle control and these kind of things. There's all kinds of really cool stuff that costs a lot of money out there. But yeah, that's kind of where my mind's going towards. Any other? What's that?
Can you get some bigger motors to move the actual doors?
Yeah, you could. It's just controlled by a relay, right? So the relay itself, it doesn't have to, the Arduino doesn't have to power 120 volts. It just has to turn on a relay, which turns on the power, the 120 volt power. So yeah, you can absolutely do it with a full-size motor. Yep.
So can you talk a little bit about the Raspberry Pi pinouts and how Arduino's, how does the communication? I'm not too familiar with it.
Yeah, so the Arduino has its pins and the sensors are connected to the Arduino. And one of the reasons I could have just used the Raspberry Pi itself, but I had this Arduino laying around and I've never really played with it, so I'm like, it's time to figure out a use for this thing, so that's why I used it. So it reads the data and it prints to serial. The Pi is connected with a USB cable from the Arduino to the Raspberry Pi. So there's no pin connections between the Arduino and the Pi, it's just a serial connection via USB. And I just read that serial from the Pi. Does that make sense?
So you don't use the actual pinouts on the Raspberry Pi?
I do use it for the motion sensor. I think that's the only pins on the Pi that I'm using though. Yeah, most of the sensors are connected to the Arduino itself.
Okay, one other question. You're not using Python in any of this picture?
No, I don't like Python. It's okay, but I like Java, I like Groovy, and I'm comfortable with it. And I guess, like I said, I do use it as my playground for learning new things, but learning C++ was enough for me. Man, and plus the Arduino has such a small, you really have to think about the code you write because it can't store like a 50 meg jar file. It has no operating system or JVM, but that's besides the point. You have to really think about your code on the Arduino. That's why they use all those pointers and stuff that is like way up here. Yeah.
What would be the cost of this project approximately?
Say again?
Like the cost?
The cost? $150, $200. So the Pi is $35, $40 plus you need a power cord. So your Raspberry Pi are about $50. Arduino's like $5. They're cheap. That big gray case that I mounted everything in was like $35. It's actually from Home Depot. It's a sprinkler system control box. And the reason I bought that is because I figured if I eventually did put it in the barn, it's weather tight and sealed and all that. The water level sensor was probably the most expensive thing in that thing. It was like $50. And that's just because, submersible electronics are not really easy to do. Most of it I got from Adafruit or Amazon. Wires and sensors. The sensors are cheap. You can get them for $2-3. But I would say about $150 total and all that material. The camera was like $20.
What about the recurring power cost?
That's zero for me. Yeah, I mean, let's be perfectly honest. The way I've architected this thing, it's not going to be cheap if you were to really pay for that bill. Which is why I did it, right? Because I had unlimited account and it makes a cool demo. But yeah, it would probably be like $1,000 a month if I were paying for that. I would make some different decisions in my architecture at that point. Yeah.
How do you connect it the USB to USB?
It's just a.
Is it a different cable? Is it a special cable?
No, it's not. The Arduinos usually come with the USB. It's kind of got like a square, funky out of the Arduino, but it's just a USB 2B on the other end of it.
How does the handshake work? Who's sending and who's not sending? How does the handshake work?
That's a good question.
Serial, I know that is.
The Raspberry base is the host. It's like any other piece, Raspberry base is the host.
Yes. Correct. Anybody else?
Yeah, with this setup you can also extend it for more of the home automation.
Yeah. Absolutely. Yeah, lights and all that. I haven't gotten that far yet because I have some TP-Link Casa stuff at home that I use, and their app's pretty good. But I haven't gone that far with it yet.
Do you plan on doing any gardening?
Gardening?
Automated irrigation projects?
So I could do that. I had a garden a couple of years ago, and I did think about that because they have moisture sensors that you could put in the ground. And I even had a rain barrel, and I was connecting. I'm like, man, I could really kind of hook up a solenoid and pump the water and detect the level. I never got that far with it, but that would be another cool thing to do. There's so many things you could do, so many projects, and man, what was it the other day? I thought of something I could automate, and I can't for the life of me remember it now, but it's a great way to learn things, right? Because it's something that's fun, it's interesting, it's not too expensive, and it keeps you writing code that's fun, right? And when you solve a problem, or at least, I don't want to say solve a problem, but when you do something fun like this, you're really kind of tying that learning to something that's fun. You're not just writing a boring to-do app, and how can I learn Micronaut? Oh, let me write a to-do app. Well, big deal, how many of those have you written in your life? You're just doing the basics. But when you kind of solve a problem like this, I'm like, okay, I need to read serial from Java. I've never done that before. You get to kind of find solutions to different kind of facets that you might not normally dig into. I wanted to learn Micronaut, so I'm like, well, I'm going to rewrite. Last week I rewrote this thing in Micronaut, and yesterday I like Micronaut so much I've already written a commitment and submit a PR to Micronaut for a feature enhancement. It's like just gets you into learning new things in a kind of a fun way. So that's never a bad thing to me. I mean, I get paid. I always loved being on stage and acting, so I get paid to. I majored in journalism, and I love code. So I have the greatest job in the world. I get to write code, write blog posts about that code, and then come talk to people about that code. It's like the greatest job in the world, so I'm lucky.
Basically, once you start with doing anything with the microcontrollers,
Mm-hmm.
Micro Center
Nice.
Under $10.
That's-
Register to buy more. You just want to get one at a time, otherwise you charge for $10 a second.
Yeah, Micro Center is awesome. I love that store. Too bad it's like 2 hours away from my house. Well, probably a good thing, otherwise I'd be broke. Man, I have a Raspberry Pi Zero at home, and that was part of what I was thinking of the other day, and now I can't, but little pieces are coming back to me.
And it's got a connection, a micro USB connector on it.
Yes.
You don't have to have a cable.
You do have to, well, no, the new ones have wireless, right? The 0W. The one I have doesn't.
It's also got 2 micro USB ports on it.
Okay.
So you plug it directly to your laptop to put the OS onto it.
Right. Yeah, the whoever was asking about the serial connection from the Arduino, that's also how you actually get your code on your program onto the Arduino. You just connect it with that USB cable to your laptop, and from the IDE itself, it compiles and pushes via serial. So that's how the program itself actually gets on there. So that's really the main purpose of the serial port, I guess. Everybody here uses Java? What other program languages do you use? Go? Really?
Clojure.
Yeah? Python? Any Node? Yeah? Cold Fusion. I liked Cold Fusion, but Adobe just did bad things with it, and it never really grew into what it could have been to me. They were more interested in making money than writing a language that developers wanted to use, to be honest with you. Yep.
Like as I said, also, if you're just like Arduino, they've got kits out there for like $35. It's basically Arduino and
All the sensors, breadboard, jumper wires. Yeah.
for $35, and it was like, that's how I got started 2 weeks ago. We were talking about it, and I said, oh, you were talking about all the stuff you're buying. I went, yeah, I've already bought a empty plastic box with the other stuff I'm starting to put in, and like, you know, all the stuff's like, try this. Let me go back onto Amazon and order this. Right, where do I put it? Amazon, I need a plastic box. There. Amazon, happy.
You can get stuff really cheap from like DHgate or Alibaba, but you have to wait a long time for them to get here. But you can get it really cheap if you're not in a big hurry. You could go that route with it. I mean, you can get like 10 sensors for $1. Yeah.
That's like Radio Shack type of stuff, which you don't get it now. In college, I used to go and buy like resistors, capacitors.
Mm-hmm. Yeah, one at a time. Yeah, I miss Radio Shack. When I moved to Blairsville, we actually still had one, but they've closed it down since then. I think they're all gone, aren't they? Yeah. Yeah, Micro Center is the only place. Target started selling Raspberry Pis, actually. Fries. Are there fries down here? Oh, I didn't know that. Oh, God, don't tell me that. I went to the Target, was it exit 10 on 400? There's one.
No, there's one on, it's exit
11?
Right from fries, right across.
Right across from Fry's. But they're like impossible to find, and the guy didn't even know they sold them, but I had seen them on their website, and it said they had them in stock, and I'm like, well, you got them somewhere. He's like, I don't know. Yeah, go figure. So Scala, Clojure, so a lot of JVM stuff. You guys pretty much stick to the JVM? Yeah? Swift. Yeah? C#. I don't mind C#. I really don't. I mean, it reminds me so much of Java. I mean, honestly, except for their kind of weird conventions with some of how they name things, or like capital letters and all that. Does anybody play with Raspberry Pis? Wow. So you've used Python mostly with those, or have you tried Java yet?
Java.
Yeah? So you use Pi4j?
I put it on and played with it for about half an hour, and it did what I wanted to do, and
then you moved on. So the version 1, when I first started using it, there was some issue with it where it couldn't read certain sensors, but I think they've resolved that now, and I know it works perfectly with this one. So if you haven't used it in a while, check it out now, because it overcame, I can't remember the exact issue, but it was something that had to do with like super user permissions that it required, but that's gone now. What else? Who else uses Raspberry Pi? What do you do with it?
GPS sensor.
Oh, cool. Yeah. Where? So,
I work for a company that actually, that's what we actually do.
Oh, really?
I don't work with that company anymore. Back when I first introduced to it, never knew about it before. They had to use it for that.
So they had a commercial product that they created with it?
If you're on the street, the most noticeable product is if you're on the street and you see the sign that tells you how fast
Yeah.
the speed limit is, we equip that with high-speed cameras to look at your plate and actually send you a ticket. But we also need to know where these things are located. So we put that in the box with everything else.
Sweet. And how did you power it? Solar?
No, there is actually batteries that are on that.
On the unit? Yeah. See, I've thought of doing something like that, but with like solar power and not only GPS, but using GSM. Did you use GSM as well for mobile data? How did you get the data off of that?
There's another board that's on there, so the purpose of the file was just to get the GPS location, and then that would feed into all the stuff that gets it out.
Gotcha. Yeah, I've thought about making like a little trail cam type thing. I mean, not that you can't buy them cheap nowadays, but it's more fun to build, you know? I mean, self-contained and battery powered and maybe solar powered and all that. So that's one thing I've thought of building, which I've already built half of it with the motion sensor and the camera and whatnot on this. Who else?
I use it for the home security system.
Yeah?
So there is an open source software that you can run on the Raspberry Pi. And I had a lot of extend devices lying around. And so what I did is we have a library that you can use it to control your extend devices. So
Control your what?
Extend.
X10.
Yeah. So it's an old protocol, but there are a lot of, you have door sensors, motion sensors, and nowadays we have the newer, everybody's coming up with their own security protocol and security devices.
Right.
But that was universal, it's a text-based protocol that can be used on. But there's open source software which can run on the Raspberry Pi. And it has a nice UI, so you can use it you can use a browser to control it, or you can use it even phone. And it's nicely written UI, and if you open it up to your router, then you can access it over there. So,
What's that called?
OpenHAB.
OpenHAB?
Yeah, Open HAB.
Okay.
Automation. But you can pretty much they have libraries for connecting all kinds of sensors. And you can connect Zigbee or Z-Wave or even Apple devices, or you can have written libraries too.
Does
I mean, it's by itself the software, and then it has modules that you can
Like plugins type of thing?
So I'm going to ask you the UI you wrote it, or are you using?
Yeah, I wrote that.
Yeah, but you try OpenHAB. It probably has interface to interface the sensors, so you don't have to write UI. You can create a UI and pretty much do it.
We all are Java developers, so I wouldn't expect you to write nice UIs.
Oh.
That's the reason I open it.
I'm kidding. Kinda. Hey, I work for Oracle. Some of our UIs suck. I mean, it's the truth.
Java's beautiful in some way.
Gets the job done.
Yeah.
What else?
I made a surveillance camera.
Oh, yeah?
And it has pan and tilt, and I can log into it.
So can you remotely control the pan and tilt? Nice. With the app or? Okay. I wanted to play with like an analog joystick with something like that, where you could do the pan and tilt and all that. That's on my list. But those are analog, right? And that's the kind of tricky thing. And that's one of the other reasons I use the Arduino is some of the sensors that I use are analog, and the Arduino can handle that. The Raspberry Pi, it's all digital. So unless you get like an ADC, analog to digital converter, which look kind of like a pain to wire, like they're not as simple as you would think they would be. So I read the analog with the Arduino and pass it over to the Pi and deal with it from there. But yeah, that's cool.
I've played with Node-RED. Have you heard of that?
Node-RED, that sounds familiar.
It's something that runs on Node.js, and it's a visual programming system for building up IoT kind of applications. So you can use MQQT and things like that with Azure.
And it like detects whatever you plugged in, right?
Well, what it is you kind of drag and drop off of a palette. There's all sorts of libraries. One library I got allowed me to build a chatbot.
Oh, nice.
With Telegram. So I actually built a chatbot in Telegram using it. But I've also used it to hook from. I also ran it on my PC and hooked it to an Arduino.
Mm-hmm.
And I had a program on the Arduino that was read from the serial port and then had a 7-segment display, and whatever number I pressed, it would show up on the 7-segment display using the serial.
Nice. I want to build a Nixie clock. Do you ever see those? They're like the old glass tube with like the numbers are, there's like 6 glass tubes, right? So 2 for hours, 2 for minutes, 2 for seconds. And they're like they almost look like vacuum tubes, but they have like almost like a neon inside for the numbers. And there's kits you can do those with the Arduino too, but those are, again, expensive. That's why I'm glad I don't live near Micro Center. All right. Anything else? Yeah.
I did a Arduino parking radar sensor where you won't park too close or too far. So that has the distance sensor and then like 2 LEDs, red and green. Actually, I was helping my son last year in projects.
Oh, cool. So like if you're too close,
Yeah, you don't get too close or you don't get too far. Then the garage will
my wife needs one of those.
Just get it, Sam.
Yeah. Now see, that is a valid point. But when I did the first version of the barn thing, I put something on social media or something, and the guy's like, just buy a timer for the light. And I'm like, yeah, I could, but I wouldn't learn anything, And when horse and buggies were around, if we would have just said, that's good enough, where would we be as a system? I'm not saying I'm innovating the next world-changing technology, but it's what keeps us learning and going forward as a society to keep questioning, what if I built this myself? And, maybe you will come up with something kind of cool. But yeah, the tennis ball always does work. You always fall back to those. That's the analog solution.
Says nothing to the cloud.
Exactly.
Says nothing to the
That's
cloud.
right.
But then I have data that shows my wife always goes forward and almost hits the wall anyway.
Well, you could put a kill switch in the vehicle.
That's when it goes.
Right, yeah, that would never go bad. Tesla. I saw something on Reddit the other day. Imagine being the first person that has a pizza delivered by someone who dies in a self-driving car, Because it's going to happen at some point, right? I mean, self-driving cars, these are the things we don't think about with technology. One day someone's going to pull up and not be alive. Kind of morbid, sorry. That's Reddit for you.
If you want to the helping your wife part with the children with bad motor skills, call up Ohio State Medical School. They have a team what that team is working on is getting around having a spine, but the design of their technology is to be able to read information coming from the brain to output a person's human motor skills. So you could probably ask if they have some kind of API or something, or something you can do with that to just read a chip.
Yeah.
Because all they do is place a chip inside of the person's skull.
Really?
Yeah.
So last year, were you at the We Rise conference? There was I can't remember his name, but he did a talk on basically reading neuro waves with Node.js. And it was really cool, but it was kind of similar to that. Obviously, probably nowhere near as advanced, but...
No, because they took a guy who was a quadriplegic, and they got him to play guitar here.
Thanks for coming. Yeah?
Yeah. It was
just
really,
with his brain?
Yeah. His spine was completely unusable.
Wow.
And they just went around it.
That's awesome.
Yeah. So you could probably call them up and ask them, if you could just create something small, not like a full glove, but maybe a subdermal insertion that'll read those specific actions.
I don't know if Towns County school system would be cool with us, like implanting chips in kids.
For science, though.
Might need a waiver for that.
Yeah. But you never know. You could get that research team to pay for it, because that is valuable information on what could
I'll have to look
eventually
into
lead
that.
to fixing that.
I'll have to look into that. That's cool. Well, thank you all very much for coming out. I appreciate it. I hope you enjoyed it, and hope you learned something. Reach out to me if you have any questions. Thank you.